Good day. So this is module 2, and I am presenting to you other vector operations, specifically dot product and its application. So let's have the definition of dot product. The dot product, denoted as u dot v of vectors u whose components are equal to u1, u2, u3, and vector v whose components is equal to v1, v2, v3, is the scalar u dot v equals u1 v1 plus u2 v2 plus u3 v3. So in other words, the dot product of the two vectors u and v is just multiplying the components of your two vectors in their respective positions as well as adding them. Then we have here the properties of the dot product. So we have here if u, v, and w are any vectors and c is a scalar, then u dot v equals v dot u. For the second property, we have c times vector u dot vector v equals u dot quantity c times v and equal to c times the quantity u dot v. For the third property, we have u dot quantity v plus w equals u dot v plus u dot w. Then for the fourth property, vector u dot vector u equals the square of the magnitude of vector u. And lastly, the fifth property, 0 times vector u equals 0. One of the application of dot product is finding angle between two vectors. So by definition, the angle between two non-zero vectors is the angle theta from 0 to pi, or 0 less than or equal to theta less than or equal to pi, between their respective standard position vectors. The angle between two non-zero vectors u and v can be found by the formula theta equals inverse cosine of quantity u dot v over the product of the magnitude of the two vectors u and v. Take note that if u dot v equals 0, the angle theta is 90 degrees. If u dot v is less than 0, then the angle theta is an obtuse angle. Then lastly, if u dot v is greater than 0, then angle theta is an acute angle. For orthogonal vectors, we can say that the vectors u and v are orthogonal, meaning perpendicular also, if u dot v equals 0. Let us work on this example. It says here, find the angle between the vector u equals I minus 2j plus 2k and vector v equals negative 3i plus 6j plus 2k. So I have here the formula for the angle between two non-zero vectors u and v. And this is theta equals inverse cosine of u dot v over the product of the magnitudes of your two vectors u and v. So let's start by rewriting your two vectors in component form or bracket angle notation. So we have here your vector u equals, you have your I, which is now 1, negative 2j, you have negative 2 and 2k, so that's 2. So we have 1, negative 2, 2. Then your vector v can now be written as in component form negative 3, 6, and 2. Let's perform the dot product of these two vectors. So using the formula u1 v1 plus u2 v2 plus u3 v3. So with that, the dot product of these two vectors, we have 1 times negative 3 plus negative 2 times 6 plus 2 times 2. We have, this is negative 3 plus negative 12, that's negative 15 now, plus 4, that's negative 11. Then let's find the magnitude of u and magnitude of v. For the magnitude of u, that's the square root of quantity 1 squared plus negative 2 squared plus quantity 2 squared. So simplifying, we have 1 plus 4 plus 4, that's equal to square root of 9, or simply equal to 3. For magnitude of v, that is equal now to the square root of negative 3 squared plus quantity 6 squared plus quantity 2 squared. And this gives us 9 plus 36, that's 45, plus 4, that's 49. Square root of 49 is also 7. So with that, we can now compute for the angle theta, which is now inverse cosine of the dot product. We have it as negative 11 all over the product of the magnitudes. That's 3 times 7. So theta equals inverse cosine of negative 11 all over 21. So using now calculator, the angle now is arc cosine negative 11 over 21 will give you a negative angle, but you have to add it to 180 degrees. And the answer now is 121.6 degrees. So this is the answer for the first problem. Verifying now the answer from this slide and what I have solved a while ago using the problem here. So cosine theta is found to be negative 11 over 21, and that gives you theta equals inverse cosine of negative 11 over 21, or that is also 2.12 radians, or 121.6 degrees. Take note that the answer here will give you negative angle theta, then add it to 180, so that this will give you a positive angle, 121.6 degrees. Take note that the concept of angle between two vectors is that the angle should have measurement from 0 degrees or 0 to pi or 180 degrees. Let's have the second example. It says here, find r so that the vector from the point A, whose coordinates are 1, negative 1, 3, to the point B, whose coordinates are 4, 1, 6, is orthogonal to the vector from A to the point B. So solving this problem now, so we have the concept a while ago of orthogonal between two vectors. It says that we have u dot v equals 0. It means that vector u is orthogonal or perpendicular to vector v. So we have here now, the first vector. So the vector from the point A to the point B. So that is vector u, which is the line segment AB. And we can define the components of your vector AB or vector u by getting the difference of the components, terminal coordinates minus the initial coordinates. We have this as the terminal point, and the initial point is point A. So we have 4 minus 1, 1 minus negative 1, that's 1 plus 1, then 6 minus 3, and the result is 3, 2, 3. Then you have your vector v. So this is the vector now from the point A to the point P. So that's AP, AP. So we have here now, terminal point is point P, initial point is point A. So we have R minus 1, then R minus 1 is R plus 1, then R minus 3. So using now this concept to find out the R, so we have u dot v equals 0. So we can now multiply these two vectors u and v by using the components given. So we have the concept last time, u dot v equals u1 v1 plus u2 v2 plus u3 v3. So we now have 3 times r minus 1 plus 2 times r plus 1 plus 3 times r minus 3 equals 0. So with that, we now have 3r minus 3. So simplifying, we have 2r, or expanding first, 2r plus 2, then plus 3r minus 9. So combining now your r's, 3r plus 2r plus 3r, that will give you 8r equals negative 12 plus 10r, negative 12 plus 2, that's negative 10, transpose it, positive 10. So r equals 10 over 8, and this is also now 5 over 4. So this is how we solve for r using the concept of u dot v, because it says in the condition that the vector from point A to point B is orthogonal to the vector from point A to point B.